So this is about supersonic vehicles. So these vehicles reach speeds higher than Mach 5, which are known as hypersonic speeds, equivalent to about 1 mile per second at sea level. So that's like instead of 60 miles per hour, these can go like 6,000 miles per hour. Mach is defined as the ratio of speed of the body of the body to the speed of sound in the surrounding medium. So it's basically how much faster you're going than sound in a nutshell. These use air-breathing engines, also known as scram and jet engines, and can take off from a conventional airport. Well, basically, they use air to propel themselves, but using some chemicals, they could use that air and make it into an engine. They're hydrogen fueled and they don't really need onboard oxygen, so it's good. So, the US has an X-43A and India has an Avatar. They can be used as reusable satellite launchers, which could replace costly rocket missions. Like instead of man-made missions that could fail and people could die, they could use these, which cost far less and could do the same thing at like way more accuracy. So there's less chance of failing. Um, these can be used for like a hyperplane, so it can go from New York to Tokyo in like about an hour. But something like this will cost a lot of money for just one trip because they need to use a lot of fuel, and it's more fuel condensed into a small place. So it's basically like instead of gasoline, like, which takes a lot of space, it takes a little bit of space, but it needs to power all that energy, so it costs more, obviously. Um, the technical challenge is to develop a non-rocket engine which can attain hypersonic speeds. And the scramjet engine is the most widely accepted solution because it uses air as the like how an engine uses gasoline and air to combust. This uses air as well. Like diesel doesn't use air, so it needs way more. It takes way more space. But this uses air, so it doesn't. So fuel tank won't take that much space. The second challenge is the development of advanced materials using titanium as alloys. So some of them use cryogenic fuels and they have lots of cryogenic tanks. So basically, the high calorific values of the fuels are needed, which burn completely at hypersonic combustion. So basically, lots of fuel compacted into a small place by using cryogenic tanks. So the basic requirements for hyperplane is it cannot be started from zero velocity. So it has to be going at a speed of like 1,000 miles per hour, and then the engine will start. So that itself is going to cost more to use than a typical airplane, which can take off and land whenever you want. So it basically uses magnets, and it has an MHD generator. So it uses like you know how if you, like for example at like a really high speed, it's necessary to combust supersonically. So the rate of how fast it's going, it needs to combust in ratio within how fast you're going, or else you're not going to lose fuel. So basically, yeah, the engine has to go faster. Like if the engine, the generator, the MHD generator, moves and works faster, it's going to use less gas, less air. It's going to be more efficient. So instead of a normal engine, it's going to be the faster the better. In a nutshell. So yeah, this is basically it in a nutshell. So